Hello, my name is Angela Matthew, and my experiment focuses on using styrofoam-made activated carbon as water filtration material. To begin, two of the biggest global problems we face every single year, especially in third world countries, is lack of clean water and high amount of plastic pollution in our landfills. What if these two huge global problems could be solved in a single solution? This is what my experiment attempts to solve. There are a few existing solutions to this predicament. However, none of them are really effective. I have a chart right here. The first one is turning polystyrene into concrete. However, this has a tendency to crack and it doesn't really hold a lot of weight. The second one was to reprocess or reuse the polystyrene. There's no automated process to this, which means we have to hand separate them, which also means that it's really expensive. And the third one was decomposing using worms. There are certain enzymes that will eat the polystyrene. However, they do it at a really slow rate, which requires a multitude of worms. And even if you had them, it wouldn't really be effective in the long run. The worms only decompose about 0.4 milligrams per day per worm. Additionally, if the chemical structure of polystyrene was examined, you would see that it is over 92% carbon, which means it could be theorized that with the right amount of chemical and heat treatment, it could be converted back into carbon. The increasing amount of plastic pollution and contaminated water is hurting third world countries. Is there a way to convert polystyrene into activated carbon to be used as filtration material? The first step in my research was to collect water samples from the Passaic River and test them for lead and bacteria. And then from there, we took styrofoam and we shredded up, which made it easier to melt. And then we heated it at 500 degrees Celsius for about 5 hours. And we also put briquettes on top of it to aid in uniform heating. And then after that first heat session, we moved to the chemical treatment, which was potassium hydroxide. And then from there, we went to the second heat session, which was about 300 degrees Celsius for another 5 hours. There is another chemical activator we could use, which was phosphoric acid, which also meant that it gave us a lower amount of time we needed for the second heat session. And it also gave us a higher surface area in the carbon. However, it had explosive reactions with the different materials we also needed in my experiment, so it wouldn't be effective. So from there, we should end up with a piece of carbon, styrofoam-made carbon. And then from there, we're going to go back to step one and take those water samples that were tested and pour it through the carbon. And then after we pour it through the carbon, we get the water that was filtered, and we test it again for lead and bacteria to see if there's a significant decrease in the amount of lead and bacteria found in the water. So as this research is an ongoing study, no final conclusions can be made just yet. However, I do have the results from the water sampling test kits. So, as I mentioned, this is ongoing research, which means I am also going to I'm going to resample it and also test the Hackensack River. And then I'm going to send it to a lab to get tested to get an accurate reading. Because the only test I was able to access gave me kind of an estimate, which was either a yes or no for the lead and for the bacteria. So from the lead, it was determined that I had over 15 ppb of lead. I don't know the exact number, which could mean that it's greater than 15 ppb, which is deadly because any amount of lead in the water is deadly. And then also the bacteria test proved that there was a significant amount of it in the water. This is a serious issue because a lot of people swim and fish in the Passaic River, and there are a couple of signs at various different locations at the Passaic River, but there's not enough of them to be informative. And a lot of people choose to ignore these signs or they don't speak the language that they're written in. In conclusion, this experiment solves two of the biggest global problems at the same time. Additionally, the heating up plastic, especially polystyrene, does result in carbon monoxide being released to the environment, which is poisonous to it. However, there is a solution to this. So in the bottom here, I have this little graph, and right in the middle, you see a second filter, separate to my water filtration filter. This is a air filtration filter. So from in this, the byproducts from the filtration, like the whole process, will be collected, and then in that little contraption, they will be purified and then released as hydrogen, nitrogen, and oxygen. So in the future of my experiment, I hope to be able to retest it and to see if they could be my results can be reproduced a multitude of times. If this is true, it also means that it can be done at a greater scale, which means that it can help more people in our world. Additionally, as I said, it is an ongoing study. So I also hope to be able to continue my research, which means I have to work in a lab to finish my experiment. Also, I forgot to mention, but I do intend on buying a water filter you can get online, and then taking my water I got from the Passaic River and pouring it through that filter and getting that filtered water that comes from the filter from the Passaic River and comparing that one to the filtered water of my styrofoam-made activated carbon one and seeing if my styrofoam-made activated carbon one is just as accurate or may perhaps even better than the one you're able to buy online. So here are a list of my references, and here are a couple more that I used to aid me in my research. With that said, I would like to conclude my presentation. Thank you so much and have a nice day.